Hey guys, time for video number 2 of the week. This one's going to be a bit longer because there's a lot to cover today, in case you hadn't noticed by the notes that I've posted for you. I want to hit the highlights of certain things. I think that you guys can understand the first page of notes that I gave you, but I want to make sure that you comprehend exactly what I'm talking about when I say inscribed and central angles. An inscribed angle in a circle, these are supposed to be circles, I know that they're not beautiful, but they are what they are. An inscribed angle has all 3 points of the angle on the circle. Okay, it has the vertex and the 2 chords on the circle. The lines could come outside, like so. Okay. Same thing with the central. The lines could come outside, but it has all 3 points, and the arc that it covers is pretty important also. So an inscribed angle has all 3 points on the circle. A central angle has 2 points on the circle, and the vertex is in the center of the circle, hence the name central. So if you're getting confused, just if it starts with a C, it's the center. Okay, so hopefully that helps you all remember it somehow or another. Now, inscribed and central angles also have some specific relationships to the arcs that they cut through. The first one, notice I have labeled this angle ABC in my inscribed circle. Angle ABC, the measure of angle ABC is equal to 1/2 the arc that it cuts through, which is the arc AC. Now please look at your notes for arcs and see what we are talking about when I say an arc. But it's basically the part of the circle that is between A and C and makes up the endpoints of the circle. That is a minor arc. Okay, we'll talk about a major arc in a little bit here. But also, the important thing for me to remember for this part of the video is that an inscribed angle ABC is equal to 1/2 the arc that it cuts. So in this case, it's arc AC. So if I told you that angle ABC was 30 degrees, you could tell me that arc AC is 60 degrees. Okay. Now, on the other hand, I have also done on the central angle, I've labeled it DEF. And the thing that you need to know now is, since this vertex is in the center of the circle, that's why it's called a central angle, angle E, or angle DEF, the measurement of that angle and the arc that it cuts, arc DF, is equal to each other. So if I told you that angle DEF was 20 degrees, arc DF would also be 20 degrees. Okay, so inscribed is half of the arc. The measure of the inscribed angle is half of the arc, and the measure of the central angle is the same as the arc. Why don't you give me some problems here? I'm going to give you a couple problems to work out. Okay, so here I've given you a new picture. I've put both an inscribed and a central angle on it, and I've given you the measurement of arc AC. So I'm asking you to work a little bit backwards here, and I'm telling you, if arc AC is 50 degrees, what does angle ADC measure? And then also, what does angle ABC measure? If you could go ahead and answer those questions, I would appreciate it. Okay, just a little bit about arc convention or arc naming conventions. You'll see that we talk a little bit in your notes, the second part of your notes today, about this. A major arc basically contains 3 letters. So, for example, if I were to say, what is major arc, if I was asking about major arc ABC, what I would say is, I am looking for this in green, or whatever color you want to call that. That would be a major arc. So this would be major arc A, B, C. Notice 3 letters. We have to say A to B to C. If I was looking for a minor arc, if I was trying to identify the minor arc, let's see if I can find a little bit nicer color than that one was for the minor arc, because in this class we'll deal mostly with minor arcs. But this highlight from A to C of a minor arc, that is AC. So typically, if you're looking at a major arc which is more than 180 degrees, look at the definitions that I wrote in your notes. Then you're talking about 3 letters to show that you're going all the way around. And if you're looking at a minor arc, like A to C, like we'll be talking about mostly, it's done in 2 letters. So that's a little naming convention that certainly some students have a difficulty with. And of course, a semicircle is just half a circle, guys. So basically what happens is you're going through the center of the circle and you're creating a diameter. So for example, if I were to draw this, ABC, I could put a point D here, and I could say that I have arc ADC, and since it's going through the diameter, creating a diameter and going through the middle, you know that this is a semicircle, and you know that the measure of that equals 180 degrees. Goodness gracious. It is not being very cooperative with me right now. There we go. Okay, so I think that's enough about arcs for right now. There are some really good examples in your notes of the different types of things that you can do, knowing that you have talking about arcs and inscribed angles and central angles. What I would like to do is do a couple of problems that aren't on your notes, so that you can take a look at a couple of other things. Okay, so one of the things that we'll be working with and should be really easy for you is the arc addition postulate, and it is exactly like the angle addition postulate. If you have 2 angles that are adjacent to each other, in other words, share a side, and you want to know the measure of the entire angle that those 2 adjacent angles make, all you do is add the angles. So for example, if you had a 30-degree angle and a 40-degree angle next to each other, the sum of those 2 angles is 70 degrees, so the measure of that angle, those adjacent angles, would be 70 degrees in total. Same thing with 2 arcs. If you have 2 arcs that are adjacent to each other, which means that they share a point, then the sum of the bigger arc is the sum of the measures of the 2 little arcs. So I'll draw you a little picture of that, and we'll take a look, see that, and it's very straightforward. Okay, so take a look at this example. I've drawn a circle with a center D and points A, B, and C. So if I wanted to know the measure of arc ABC, and I already knew the measure of arc AB and the measure of arc BC, all I'd have to do is add them together. So let's say the arc AB is 60 degrees, and arc BC is 55 degrees, then major arc ABC would just have to be 60 plus 55, which equals 115 degrees. Okay, this actually comes up in some significant problems, so and students have a tendency to forget about it, so try not to forget that this comes up. It's really easy, and it makes life a lot easier for you guys too. Okay, so to wrap this up, it's not really too much longer than yesterday's, but this might take you a little bit of time to answer this question. I have given you a circle with 6 points. C is the center of the circle. You have minor arc AF, which is 44 degrees. that is not cut by a central angle, it is cut by an inscribed angle, ABF. Okay, you know the angle EDF is 15 degrees. I will tell you that BCF is indeed a diameter, so that should tell you about something about arc BAF, and also, the other half of the circle. But anyway, what I want you to do is I want you to take this information that you've been given, and I want you to find the measure of angle ABE. Take your time, think it through, use some paper, use pencil, use your brain. It's not difficult, but you got to be careful. And of course, this is the last thing that we're going to do for this. After you've done this and done your video, I want you to go ahead and do your homework. If you get your homework done early, obviously you have Alex to work on, and I am hoping that I will be back on Thursday. That way I won't be out all week, but I know I'll definitely be out on Wednesday, tomorrow as well. Anyway, hope you guys have a good day, and like I said, I hope to see you on Thursday.